Welcome to all in this video lecture series of computer networks. My name is Deepak Aneja, Assistant Professor, ABES Engineering College. IPv6, the network layer protocol in the TCP/IP protocol suite is currently IPv4. Although IPv4 is well designed, but due to fast growing internet, each and every device is onto the network. We are switching to the IPv6 because of its large range. So the header includes base header. This is of 40 bytes. And next is payload. Payload is datagram. This is the complete datagram. Total size is of 65535 bytes. Next is a header format of IPv6. Decode. First field is a 4-bit field which define the version of the IP. Next field is 4-bit field which determine the priority. Next 24-bit is of flow label. Then 16-bit field is of payload length. 8-bit field is of next header. Next header. And 8-bit field is of hope limit. Then the source address. This is 32, 32, 32, total 4. 32-bit into my 4, this is 128 bits. Next is same 1, 2, 3, 4. This is the destination address. This is 32 into 4, 128 bits. As we know, it is the IPv6 is of 128 bits and it is hexadecimal notation. Hexadecimal representation. Of 128. Let us discuss about the frame format of IPv6. It is of 40 bytes base header. 40 bytes base header. It is also called next generation protocol. Next generation IPNG. So first field is version, which defines the version of this IP protocol. The latest version is IPv6, so the value of this field is 6. Next field is priority. This is 4-bit field, which defines the priority of the packet, which is important. So through this field, we can define the priority of the packet. If the priority is high, so this packet is delivered first in respect to the low priority frame. Next field is flow label. Flow label is 24-bit field, which is designed to for providing the spatial handling for flow of data. Spatial handling flow of data. This mechanism can be used to support the traffic such as real-time audio and video transmission. Next 16-bit field is of payload length. This is 2-byte field which defines the total length of IP datagram. Total length of IP datagram excluding base header. So in this, the size of header is fixed, that is 40 byte, and this payload length defines the total length of datagram excluding base header. Next field is next header. This is 8-bit field. This is used to point the next header of the next datagram. So it is 8-bit field which defines the header which follows the base header in the datagram. This will point the next datagram header. If suppose this is the last or only fragment, so the value which in this field is which defines which the upper layer services uses this IP protocol. That will be TCP or UDP. So which upper layer protocol uses the services of IP datagram, IPv6, in case of the last and only fragment. If there are many fragment of this datagram, then this field points the next header. Next is hop limit. This is 8-bit field similar to TTL. This is the lifetime of the packet. Maximum is 255 seconds. Next is source address, which will define the IP datagram is originating from the source host. This is the hexadecimal address, 128-bit address. Similarly, this is the destination address where to transmit the frame. This is also the 128-bit hexadecimal address. Now, here comes the one important question. What is the comparison between IPv4 and IPv6? So first comparison is IPv4 is of 32-bit address and IPv6 is of 128-bit address. So the next is representation. The representation is dotted decimal. Dotted decimal in IPv4 or in IPv6, it is hexadecimal. Third point is the size of header in IPv4 minimum is of 20 byte and maximum is of 60 bytes. And in IPv6, this is 40 bytes. And fourth one is there is header checksum field. Field is available. There is no header checksum in this. So this is one important question that comes in the exam, comparison between IPv4 and IPv6. So next is transition from IPv4 to IPv6. Because of the huge number of systems on the internet, the transition from IPv6 to IPv4 to IPv6 cannot happen suddenly. It takes a considerable amount of time before every system on the internet can move from IPv4 to IPv6. So some systems are recently using the IPv4 and some are switching to the IPv6. So the transition must be smooth to prevent any problem between IPv4 and IPv6. For this purpose, there are three transition strategies. First one is dual stack. Second is tunneling. And third one is header translation. Header translation. So the first one is dual stack. In this, this is the transport upper layer. Here is a network layer. Here, some system uses IPv4 and some system uses IPv6. So this is underlying technologies. Lemon, or you can say lower layer, physical plus data. So some systems that are using the IPv4, some system that are using the IPv6. System. Six system. So it is recommended that all hosts before migrating completely to version 6 have dual stack of protocols. In other words, a station must run IPv4 and IPv6 simultaneously until all the internet users uses the IPv6. So this is the dual stack. Next is tunneling. Next is tunneling. So in this, there is a host computer, or this is the destination host. Both are using IPv6, IPv6 host. Both are communicating via router. These routers are currently using IPv4. So here create a tunnel. Six header. This is payload. Here is also IPv6. This is the payload. Here uses IPv4, IPv6. So tunneling is the strategy used when two host computers using IPv6 and want to communicate with each other. And the packet must passes through the region of that uses the IPv4. So for this packet must have IPv4 address. So IPv6 packet is encapsulated encapsulated in IPv4 packet. When it enters the region, it leaves its capsule when it exits the region. So whenever required, it uses the IPv4 header format When it leaves this region, it it leaves its capsule. Then it will come to the IPv6. So it seems like IPv6 goes through a tunnel at one end and emerges at the other end. So IPv4 packet is carrying IPv6 packet as data. So this is the tunneling strategies. Next is header translation. In header translation, there is some header translation procedure that we have to follow. First, IPv6 mapped address is changed to IPv4 address by extracting the rightmost 32 bits. Second, the value of IPv6 priority field is discarded. The type of service field in IPv4 is set to 0. Fourth, the checksum for IPv4 is calculated and inserted into the corresponding field. Fifth one, IPv6 flow label is ignored. Sixth, compatible extension header are converted to options.